The solar storm we have experienced has been very intense, category G5, the most extreme since 2003 according to the Space Weather Prediction Center, and it worries the scientific community, as it has produced northern lights in many continents and countries on Earth, even in mid-latitudes. This phenomenon is typical of polar regions, but many believe that this is only the prelude to a greater solar storm that could end our technological civilization. The so-called Carrington Event that already occurred in 1859, but at that time the most advanced technology we had were telegraphs that collapsed due to a huge colossal solar storm. Today we will talk about a phenomenon that seriously worries us, also when it can happen and what will happen to us exactly. To understand the scope of what we have suffered and what awaits us, we must understand what the northern lights are, and why the sun produces solar storms. Why do solar storms occur? The sun, like every star, is constantly active and releases large amounts of plasma into space during its periods of maximum activity. Plasma is the fourth state of matter, composed mainly of electrons and positive ions, and is the most abundant state in the universe, forming stars, the interplanetary medium and most of the interstellar medium. Solar storms are also called geomagnetic solar storms, and are explosions on the sun that launch charged particles towards the Earth. They do not occur with predictable regularity like clockwork. The frequency of solar storms varies according to the solar cycle, which is a cycle of approximately 11 years of solar activity. During the solar cycle, the sun's activity experiences fluctuations, reaching a maximum and a minimum. This activity is mainly driven by the interaction of magnetic fields in the solar atmosphere and the release of energy stored in these magnetic structures. One of the main causes of solar storms is the presence of sunspots, dark areas on the surface of the sun where the magnetic field is very strong. These sunspots are the result of the concentration of magnetic flux on the solar surface, which can cause solar flares and coronal mass ejections. People with eclipse glasses can also look for sunspots during the day. Solar flares are sudden releases of energy in the solar atmosphere that can trigger the emission of charged particles and electromagnetic radiation into space. Coronal mass ejections, on the other hand, are larger explosions that involve the release of huge amounts of solar material, mainly plasma and magnetic fields, into outer space. Unlike solar flares that travel at the speed of light and can reach Earth in just over 8 minutes, coronal mass ejections are slower and travel at about 800 kilometers per second. So experts must wait to better forecast the impact, especially when they are at a distance of 1.6 million kilometers from us. Northern Lights. The Northern Lights, also known as the aurora borealis, are natural phenomena that occur when charged particles such as electrons and protons, coming from the solar wind, collide with the Earth's atmosphere near the magnetic poles. They are usually seen in green colors in the polar regions, and it is due to the excitation of oxygen, also responsible for other yellowish tones. In other regions closer to the equator, we could experience purple, blue or reddish colors, due to the excitation of nitrogen and the curvature that produces electromagnetic wavelengths. If you want to see them, you need a clear sky free of lights or pollution. The fundamental reason behind the formation of the northern lights is found in the interaction between the solar wind and the Earth's magnetic field. The solar wind, composed mainly of charged particles and electromagnetic radiation, is constantly expelled from the solar corona into outer space. The phenomenon that we have experienced at unusual latitudes has occurred because the coronal mass ejection has been very intense, and the charged particles have been channeled towards the Earth and have penetrated deeper into the atmosphere, reaching lower latitudes than usual. This means that during these exceptional conditions, it means that throughout the next week and possibly this year, we will see auroras in places that normally do not experience them. So as you can see, the capricious dance of the northern lights is closely linked to solar activity. This cosmic dance of charged particles and electromagnetic radiation that at its peak can offer even more grandiose spectacles, but paradoxically with potentially catastrophic consequences. To understand the magnitude of these geomagnetic storms, the National Oceanic and Atmospheric Administration has established a classification system, ranging from G1 to G5, reflecting the intensity and possible impacts on technology and nature. Category G1. Category G1 is minor and causes some electrical power fluctuations in some satellites and spacecraft. Only the polar regions can see the northern lights. Category G2. Category G2 causes power fluctuations in all satellites and some minor problems in spacecraft. Although there may be radio interference, these are only isolated cases. These auroras can be visible at latitudes such as New York and Idaho. Category G3. Here we come to Category G3. Here things get a bit serious. Electrical problems can be significant in spacecraft and satellites. Satellite navigation can be affected. If there is a manned mission, astronauts may have problems with the electrical systems. During a solar storm, radiation in near-Earth space increases, which could expose astronauts to higher levels of radiation, increasing the risk of adverse health effects such as genetic damage, cancer risk, and acute health problems. Category G4. Category G4 is considered extreme and is the one with which this phenomenon began on May 10th. Problems in electrical power systems and spacecraft are significant, affecting all satellite navigation, and auroras can be seen in such unusual regions as Alabama, California, Central America, and Spain. In 2005, a Category G4 solar storm occurred. Category G5. Category G5 storms are the most extreme, and the Space Weather Prediction Center expanded its alert to this category on May 11th and 12th, and more may occur during this year 2024. There may be power outages not only on satellites, but also in the terrestrial technological infrastructure, especially in high-voltage systems. Antti Pulkkinen, director of NASA's Science and Geophysics Division, has told us that they are monitoring the damage being suffered by satellites and some key systems on the space station. NASA is seriously concerned about the safety of the 7 astronauts on the space station. Although some of its electrical equipment is protected for cases like this is not the case with radiation. And the crew must go to the best protected area of the station to minimize its effects. You can imagine what would happen on a long-duration trip to Tuesday, and we find ourselves in a solar storm of this category, without being protected by the Earth's magnetic field. If the Category G5 continues, it can cause serious damage not only to any ship or satellite, but to other technological systems on our planet. The northern lights in this case will be visible at any latitude eventually. Experts predict that a Category G5 storm is the prelude to another Carrington event. On the other hand, we have a geomagnetic storm index that tells us the geomagnetic activity of the Earth. That is, the degree of interaction with the Earth's magnetic field. It is determined every 3 hours and can vary in a range from 0 to 9. The K0 range represents the minimum geomagnetic activity, and K9 the most extreme. The one we are experiencing right now has the K9 geomagnetic storm index, and it is impressive. What can happen to us? Scientists have already detected a series of solar flares and coronal mass ejections on May 8, 2024. Flares are always associated with a group of sunspots, and these have a size equivalent to 16 times the diameter of the Earth. So they predicted that something big was about to happen. So far, the Sun has produced at least 7 plasma explosions, and each eruption is known as a coronal mass ejection, and can contain billions of tons of plasma and magnetic field from the Sun's outer atmosphere. On social media, we have witnessed an avalanche of images of the northern lights in countries where this phenomenon had never been witnessed. The recent G5 category solar storm that we have experienced has been a cause of great concern for the scientific community, and it is believed that the worst is yet to come. The Carrington Event, which took place on August 28, 1859, named after astronomer Richard Carrington, is remembered for the collapse of the media and electrical grids of the time. During the event, a solar flare released an enormous amount of energetic particles toward Earth, equivalent to 10 billion atomic bombs. The phenomenon caused a 14-hour outage in the telegraph network of Europe and the United States, and is known as the most intense solar storm in recorded history. In 1859, technological society was in its infancy. If it happened today, all satellites would stop working, radio communications would be disrupted, we would be left without electricity, and blackouts would be significant at different points around the globe. Services would be disrupted for weeks. Before the Carrington Event, there is no record of an extreme solar storm in the last 500 years. Although very strong solar storms are expected every 50 years, so we are about to approach a solar maximum that could be worrying, which reminds us how vulnerable our technological civilization is. However, things could be even worse. Scientists have analyzed radiocarbon dating back 14,000 years, and it is believed that a solar storm much more intense than the Carrington Event caused the solar rays reaching the Earth to be greater than usual. This is known as the Geomagnetic event. It is as if a giant ball of plasma were heading towards the Earth. If it happens, there would be general interruptions in the electrical supply, and it would return civilization to the Middle Ages. Not even the Earth's atmosphere would be able to stop it, so there would be widespread power outages, and it would also affect people's health. Currently, this G5 category storm only poses a risk to the Earth and high-voltage transmission lines, not to the usual power lines found in people's homes. Although there may be occasional cases of power outages, there is no danger to health from radiation, because the Earth's atmosphere mitigates most of it, so for now we must remain calm. However, satellites can be affected, especially where they are exposed to sunlight, and there is concern for astronauts. Even pigeons and other animal species have internal biological compasses that could be affected. A reduction in the number of birds returning home during geomagnetic storms has been noted, according to NASA's Jet Propulsion Laboratory. In 2003, an extreme solar storm cut off power in Sweden and damaged power transformers in South Africa. Even when the storm is over, many GPS signals from satellites could be scrambled or lost. The problem lies with Elon Musk and his army of satellites. According to him, they are holding up so far. However, since there are so many satellites, the interruptions should not last long. We have not yet reached solar maximum. We are in solar cycle 25, and according to this graph, the worst is expected by the end of 2024 and beginning of 2025. It is possible that there will be G4 and G5 coronal mass ejections, and that this could lead to a Carrington event, but it is also possible that nothing will happen at the moment. That is why it is important to study the sun and be prepared. Although our star seems calm, it has episodes of uncontrolled fury. In a society increasingly dependent on satellites and telecommunications, industries must adopt protective measures to avoid blackouts. What is certain is that we are not prepared. A young technological civilization like ours still has many challenges to overcome. Hush.